Hello, my dear students. Welcome to my YouTube channel. Today's topic is part 3 combination of resistance from chapter 4 current electricity. So, resistances can be connected in different ways. So, that's why this is called as combination of resistance. In a circuit, resistances can be connected in series or resistance can be connected in parallel. So, let us study the combination of resistances. So, resistances in series and resistances in parallel. So when resistances are connected one after the another, they are said to be connected in series. Whereas when resistances are connected in between two common points, they are said to be in parallel. So whenever resistances are connected one after the another as shown in figure, three resistances are given R1, R2 and R3. They are connected one after the another. So such a combination it is called as series combination of resistances. So in such case, current flowing through each resistance is same because current flowing it has only one path to flow. So current through each resistor is same, but potential difference or voltage across each resistance is different. V1, V2, V3 value of resistances R1, R2 and R3. When we connect three resistors R1, R2, R3 in parallel, then path for current through each resistor is different. So that's why current flowing through each resistance is different. That is I1, I2 and I3. But potential difference across each resistance is same now. So whenever resistances are connected in series, current through each resistor is same, but potential difference across each resistor is different. So we write the equation V is equal to V1 plus V2 plus V3 plus etc. Whenever resistances are connected in parallel, potential difference across each resistor is same, but current flowing through each resistance is different. So we write I is equal to I1 plus I2 plus I3 plus etc. So in series combination, we have the equation Rs is equal to R1 plus R2 plus R3 plus etc. Whereas in parallel combination, we have 1 upon Rp is equal to 1 upon R plus 1 upon R2 plus 1 upon R3 plus x dash 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 dash, that is etc. So this is called as law of resistance in series. It states that the equivalent resistance of series combination is equal to the sum of individual resistances, because Rs is equal to R1 plus R2 plus R3 plus etc. Rs in this case it is called as total resistance or equivalent resistance of series combination. Whenever resistances are connected in parallel, we have law of resistances in parallel, which states that the reciprocal of equivalent resistance of parallel combination is equal to the sum of reciprocals of the individual resistances. Rp in this case it is the equivalent resistance of parallel combination. So whenever resistances are connected in series, the total resistance it increases. It is greater than the highest individual resistances. Whereas whenever resistances are connected in parallel, the total resistance decreases and it is less than the least individual resistance. Now we will compare ammeter and voltmeter. We know that ammeter it is an instrument which measures current, whereas voltmeter it is an instrument which measures potential difference. Whenever ammeter is connected in circuit, it is connected in series with the circuit, whereas voltmeter it is connected in parallel with the circuit. So we say that ammeter it has low resistance. If we consider ideal ammeter, then ideal ammeter should have zero resistance. Voltmeter it has high resistance. If it is ideal voltmeter, then its resistance should be infinite. Now let us solve certain problems related with combination of resistances, that is series and parallel. So formula for to solve problems, it is whenever resistances are connected in series, we use the equation Rs is equal to R1 plus R2 plus R3 plus etc. Whenever resistances are connected in parallel, we write 1 upon Rp is equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3 plus etc. Here Rs it is equivalent resistance of series combination, Rp it is equivalent resistance of parallel combination, whereas R1, R2, R3 etc. these are individual resistances. Note in this case is that if current through the resistance is same, then it is called as series combination. If current through resistances get divided, then it is parallel combination. Now first problem, find the effective resistance of the following combination. So various resistances are connected here. We have to just identify where current gets divided, where current remains constant. That is, we have to first find out the combination of resistances, whether it is series combination of or parallel combination. Now between A and B, 4 resistances of 2 ohm each, these are connected in parallel. So we will find out first the equivalent resistance Rp of this parallel combination. Using equation 1 upon Rp is equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3 plus 1 upon R4. Each resistance here it is 2 ohm. So substituting the values, we will get finally Rp as 1 upon 2, that is 0.5 ohm. So in between A to B, instead of 4 resistances, we will now have only one resistance Rp, that is 0.5 ohm. So we will substitute here. Now between A and C, these two resistances, these are connected in series. So we take Rs as the equivalent resistance between A and C and find out Rs using formula R1 plus R2. Substituting the value of R1 as 0.5, R2 as 20, we write Rs as 20.5 ohm. So effective resistance of total circuit, now it becomes 20.5 ohm. Again, second circuit is given. Again, we have to find out effective resistance of this combination. So from the figure, it is seen that in between B and C, between points B and C, 3 resistances each of 6 ohm, these are connected in parallel. So first we will find out the parallel combination equivalent resistance between B and C. So let us, it is be Rp. So 1 upon Rp is equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3. Value of R1, R2, R3 each, it is 6 ohm. So substituting the values, you will get Rp as 2 ohm. Now between B and C, the parallel combination, we write only one resistance of 2 ohm and find out resistance between B and D. So 2 ohm and 4 ohm, these resistances are connected in series. So we write total resistance as Rs, and we will find out Rs is equal to R1 plus R2. R1 in this case is 2 ohm, R2 is 4 ohm. So total resistance between B and D is 6 ohm. Now we will find out resistance between A and D. So two resistances, 6 ohm and 12 ohm, these are now connected in parallel. So we will find out parallel combination between A to D. So 1 upon Rp is equal to 1 upon R1 plus 1 upon R2. Substitute the values, you will get Rp as 4 ohm, that is the total resistance of the circuit is 4 ohm. Two resistances have effective resistance of 16 ohm in series and 4 ohm in parallel. Find each resistances. Now two resistances are there, let it be R1 and R2. When they are connected in series, total resistance becomes 16 ohm. When they are connected in parallel, total resistance becomes 4 ohm. So value of Rs and Rp are given. Rs as 16 ohm, Rp as 4 ohm. We have to find out value of R1 and R2. So we use two equations for series combination as well as parallel combination. First, for series combination, we write Rs is equal to R1 plus R2. Value of Rs is given 16 ohm. So substitute here. So we write R2 is equal to 16 minus R1. Let this be equation number 1. Now we will use equation for parallel combination as 1 upon Rp is equal to 1 upon R1 plus 1 upon R2. Substitute the value of Rp as 4. Take cross multiplication. R1 plus R2 is a 16. Instead of R2, write 16 minus R1 from equation 1. Take cross multiplication. You will get R1 into 16 minus R1 is equal to 16 into 4. Solving the bracket and rearranging, you will get an equation in R1, which is a quadratic equation in R1. Solve this quadratic equation, you will get value of R1 is as 8 ohm. Find out value of R2. So again it becomes 8 ohm. So R1 and R2, each resistance is 8 ohm. Let us study certain MCQs related with this combination of resistances. So when number of resistances are connected in series, the effective resistance. So we have Rs is equal to R1 plus R2 plus etc. So in series combination, effective resistance always increases. When number of resistances are connected in parallel, the effective resistance, it decreases. To obtain maximum resistance, the given resistor should be connected. So we know that whenever resistances are connected in series, effective resistance increases. So to obtain maximum resistance, the given resistor should be connected in series. If three resistances of 1 ohm, 10 ohm and 100 ohm are connected in parallel, then equivalent resistance will be. So to find out equivalent resistance of parallel combination, we use the equation 1 upon Rp is equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3. But we know that whenever resistances are connected in series, the total resistance, that is equivalent resistance, it decreases and it is less than the least resistance. Least resistance here it is 1 ohm. So here equivalent resistance, it should be less than 1 ohm. Four resistances of 2 ohm each are connected in parallel, then what will be the equivalent resistance of the combination? So for parallel combination, we use equation 1 upon Rp is equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3 plus 1 upon R4. All these four resistors are 2 ohm each. So substitute its values. Finally, we will get Rp as 1 upon 2, that is 0.5 ohm. We can use another method also. So both the methods are correct here. You can directly find 1 upon Rp and then Rp, or directly you can find out on calculator Rp. So value of Rp here it is 1 upon 2, that is option D is correct. Three resistances of 430 ohm, 210 ohm, 100 ohm are connected in parallel. The total resistance is, again we use the equation for parallel combination, that is 1 upon Rp is equal to 1 upon R1 plus 1 upon R2, 1 upon R3, 1 upon R4, etc. So only three resistances are connected here. So we directly find out Rp, substituting the values, we find out Rp as 58.52 ohm, that is option B. A series circuit consists of three resistors with values of 140 ohm, 250 ohm and 220 ohm. The total resistance is. So in series combination, we write Rs is equal to R1 plus R2 plus R3. Substitute the values, you will get Rs as 610 ohm. The series combination of resistance is used to dash the resistance of the circuit. We know that whenever resistances are connected in series, total resistance of the circuit increases. So series combination of resistances is used to increase the resistance of the circuit. The parallel combination of resistances is used to dash the resistance of the circuit. Again, we know that whenever resistances are connected in parallel, the total resistance of the circuit decreases. So parallel combination of resistances is used to decrease the resistance of the circuit. In series combination, the potential difference across each resistance is. So in series combination, the resistances are connected one after another. So current flowing, it has only one path to flow. So current through each resistor is same, but potential difference across each resistance is different. In dash combination, potential difference across each resistance is same. So we know that whenever resistances are connected in between two common points, then current flowing through each resistance, it will be different, but potential difference across each resistance is same. Such a combination, it is called as parallel combination. The resistances 2 ohm, 3 ohm and 5 ohm are connected in series. The potential difference across the combination is 10 volt. Find out the current through the circuit. So three resistance R1, R2, R3 are given, they are connected in series. So we'll first find out equivalent resistance of series combination using formula Rs is equal to R1 plus R2 plus R3. So it is 2 plus 3 plus 5, that is 10 ohm. To find out current through the circuit, we use equation Ohm's law, V is equal to IR. So I is equal to V upon R. So it comes 1 ampere. The resistances 4 ohm, 2 ohm and 8 ohm are connected in parallel. The potential difference across the combination is 20 volt. Find the current through each resistance. So three resistances, these are connected in parallel. So we'll first find out equivalent resistance of parallel combination using formula 1 upon Rp is equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3. Substituting the values of R1, R2 and R3, we get Rp as 8/7. Now to find current through each resistance, we use the equation V is equal to IR or I is equal to V upon R. So current through resistance R1, it is I1 V upon R1, so it is 5 ampere. Current through resistance R2, it is I2 V upon R3, and similarly I2, so its values, it is 5 ampere, 2.5 ampere and 10 ampere. That is option A. When two equal resistances are connected in series, the equivalent resistance of combination is 20 ohm. The equivalent resistance of the combination when they are connected in parallel is. So here we have given two equal resistances, so we write R1 is equal to R2 is equal to RC. When they are connected in series, total resistance becomes 20 ohm. So we write RS is equal to R1 plus R2, that is R plus R. So 2R is 20, so R is equal to 10 ohm, that is R1 is equal to R2 is equal to 10 ohm. Now these are connected in parallel. So we write equation for parallel combination 1 upon Rp, it is equal to 1 upon R1 plus 1 upon R2. R1 and R2, each value it is 10 ohm. Substituting it, we will get Rp as 5 ohm. If three resistances R1, R2 and R3 are connected in parallel to each other, then equivalent resistance of parallel combination is given by. So we know that according to law of resistances, when they are connected in parallel, we have Rp. That is, we have to find out equivalent resistance of parallel combination, and it is given by equation 1 upon Rp is equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3. If three resistances R1, R2, R3 are connected in series to each other, then its equivalence resistance is given by the formula Rs is equal to R1 plus R2 plus R3. The effective resistance between points A and B is. Now as you can see, in between points A and B, three resistances, these are connected in parallel. So R1 is 3 ohm, R2 is 6 ohm, R3 is 18 ohm. So we will find out effective resistance of parallel combination using formula 1 upon Rp is equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3. Substituting the values, we find out Rp as 1.8 ohm. The effective resistance in the following diagram is. Now here we can say that two resistances of 2 ohm and 2 ohm, they are connected in parallel, and this parallel combination is in series with a resistance of 2 ohm. So we will first find out the equivalent resistance of parallel combination using 1 upon Rp is equal to 1 upon R1 plus 1 upon R2. R1 and R2, these are 2 ohm each. Substituting the values, we will get Rp as 1 ohm. Now this 1 ohm and 2 ohm, these are connected in series. So total resistance, it becomes Rs is equal to R1 plus R2, that is 3 ohm. When two resistances are connected in series, their equivalent resistance is 100 ohm. And when connected in parallel, it becomes 24 ohm. We have to find out the two resistances. So we use both the equation for series combination as well as parallel combinations. So first we will use equation for series combination as Rs is equal to R1 plus R2. Whenever resistances are connected in series, its value is 100 ohm is given. So we write 100 is equal to R1 plus R2. From this equation, we write R2 is equal to 100 minus R1. Now whenever resistances are connected in parallel, we use equation 1 upon Rp is equal to 1 upon R2 plus 1 upon R2. So parallel combination resistance is given 24 ohm. We will take cross multiplication and have an quadratic equation in R1 as given here. Rearranging and taking its equation, we will find out value of R1. It will be as 60 ohm or 440 ohm. So when R1 is 60 ohm, R2 is 40 ohm. When R1 is 40 ohm, R2 is 60 ohm. So the two resistances in this case, these are 60 ohm and 40 ohm. Thank you very much. If you like this video, you can like and subscribe to my YouTube channel. Thank you very much.